This video will be problems 26 through 30 from the 2009 released OGT test. Problem 26 says a banquet center offers a choice of 3 salads, 5 main courses, and 4 desserts. How many different meals can be created by selecting 1 salad, 1 main course, and 1 dessert? So there's 2 ways to think about this. The first way is to create a list, but that can take a while. You could say, suppose I select salad 1, and then I select the first main course option, and then I select the first dessert option. Well, what if I did almost the same thing but selected the second dessert option, dessert 2? And what if I did the same thing and selected the third dessert option? So you could go through and create a whole list cycling through all the different options. That can take, like I said, quite a while. So the shortcut way is you can actually just multiply the options together. If we do 3 multiplied by 5 multiplied by 4, we get 60 total options. So anytime you see this, how many different can be created by selecting 1 of each, you just multiply the options together. Question 27, Joel has a 50-meter roll of copper wire that weighs 7.5 kilograms. Approximately how many meters of wire will be in the new shipment that weighs 502.5 kilograms? So it's important on these types of problems to know which ones go together. So the information for the 50-meter roll was that it weighs 7.5. And then the second set of information, how many meters we are trying to find, that's where we'll use our variable x. And that goes with a weight of 502.5. So when you have that 2 sets of related information, this is called a proportion problem. We're going to set up 2 fractions, one with the first set of information. We had a 50-meter roll over 7.5 kilograms. So this all came from that first set of related information. So then we're going to use the second set of information, but we have to put it in the right order. Maybe it's x over 502.5, and maybe it's 502.5 over x. To determine that, we have to line up and relate top to top. 50 meters was our top number here, which means meters also needs to be the top of the second fraction. So it was x meters, so our variable will go on top. And then the weight also has to relate. Bottom will both be the weights from the 2 sets of information. So that's where we put our 502.5. So to solve something like this, you do something called cross multiplication. I'm going to rewrite it since I have a lot going on up above. So to cross multiply, you take the bottom right and multiply it up to the top left. The ultimate goal is to get rid of all the fractions. We don't want any division left. So 50 times the 502.5, and then we do the bottom left multiplied by the top right. So the 7.5 times the x. Now we plug the 50 times 502.5 into a calculator. Sometimes I forget I have to either clear it out or go to a new row. So I cleared it out, and we're going to multiply 50 times 502.5, which is 25,125. Now we're left with an equation where we need to do an opposite. This is multiplied by x, so we need to do the opposite and divide. When we do that opposite, we just plug it into the calculator again. I'm going to do 25125 divided by the 7.5, which gives us 3,350. So now we can scroll up and select our correct answer. So we know this is a proportion problem because it had 2 sets of related information. Question 28. Frank makes and sells small picture frames. His revenue from sales can be represented as R equals 1360x for x frames sold. So revenue is the money you get from selling items. You might have to take into account that you've spent money to make those items. That's what the C coming up is the cost. So there's revenue, there's cost, and there's profit. Profit is the money you actually made because you have to cover all of the costs first, and then there's the extra left over. That's your profit. So the cost of making the frames can be represented as C equals 5.80x plus 120 for x frames made. In your answer document, determine the minimum number of frames Frank must make and sell in order for his revenue to be greater than his cost. Show your work or provide an explanation for your answer. So we want revenue to be bigger than cost. Again, there can be two ways to do this. You could set up an equation, well, actually in this case called an inequality since we're doing greater than. So you could set up an inequality and solve for x, or you could do a guess and check version where you actually guess an amount of frames and see, well, does this make the revenue bigger than the cost? If we set up our inequality, it said revenue is 1360. And cost is 580 x plus 120. So to solve an inequality like this, we have a variable on the left and a variable on the right. We've got to get those onto the same side. Our inequality sign splits this into two sides. So to do that, we have to do opposite operations. So since this is a positive 5.80x, we want to subtract it. When there's only one variable left, we end up dividing, but when there's more than one, we have to do the opposite of addition or subtraction. So 1360 minus 580 is 7.8. And you can keep the 0 if you want, or you can just drop it. It means the same thing. So now that there's only one variable left, now is where we divide. When there's a number next to the letter, and all you want to move is the number itself. Here we wanted to get rid of the variable as well. Here we're going to just divide by the 780. And on this side it just cancels. It gets rid of the 780. And then we do the 120 divided by 780 to get 15.38. So you can't have part of a frame. So we have to figure out how to round this number. Normally when you do rounding, your goal is just to look at the number and decide, is it going to go up or down based off the number next to it? Would this be 15 or would this be 16 based off the 3? Because this is an application problem, we have to think about it a little bit more carefully. So if he wants his revenue to be bigger than his cost, if he makes 15 frames, that will be close. It will be almost bigger than his cost, but not quite. So in one like this where we want it to be bigger, we actually have to round up. Can't have part of a frame, and we need the revenue bigger than the cost, so we have to round up to 16. So that's the number of frames we need. Now, if you don't remember how to do this inequality setup, the second option is to literally guess and check. Revenue needs to be bigger than cost, so we're going to take revenue and say, well, I think maybe it's going to be 5 frames. And if we have 5 frames, it's going to be bigger than the cost of making 5 frames. I have to scroll over, plus 120. So we have to plug each side into the calculator to get the revenue. So if he sells 5 frames, he makes $68. If he makes 5 frames, it costs him, oh, I forgot to go to a new line again. I'll clear it out. So 5.8, 0 times 5 plus 120 is 149. So this is not true. Revenue is not bigger than cost. So 5 was too small. So I would jump up to 10 and try 10. And if you write this workout or discuss that you guessed and checked and looked for the cost and revenue for a certain number of frames, then you can still get full points even without setting up that entire equation and solving. So we try 10 frames, costs $136 to make 10 frames, or sorry, to sell 10 frames, and it costs 580 times 10 plus 120. Nope, and I messed up again. I hit backspace too much. 70. Sorry, I forgot the 0 as well. 178. Always double check that you're typing things into the calculator correctly. It's easy to make a small mistake like that. So still not true. 136 is not bigger than 178. So we jump up again. And so you follow that process until you find where it goes from being smaller on the left and bigger on the right to being bigger on the left and smaller on the right. So you would keep going and trying until you get to that point where you can find where revenue is bigger than cost. Question 29, similar trapezoids are shown. What is the value of n? So normally with similar trapezoids, they would give you corresponding parts. They give you a 6 and 9 that corresponds. Those are both the top of the trapezoid. But the part we want, n, has no corresponding part on the smaller trapezoid. They did give us the 4 so we could find this line, but the fact that they didn't give us the bottom makes this a much more difficult problem. So even though there is a more mathematical way to do this, this is the kind of problem I actually recommend kind of eyeballing. So we know this top line is 9, which means the same distance on the bottom, so to about here, pretend that's a straight line going down, this distance is also 9, which means we just have a little bit more than 9. So we have a couple that are a little bit more, 10's a little bit more, 12's a little bit more, 15 is starting to become a lot more, and 19's definitely a lot more. So not C or D. And then this doesn't look like one more unit to me. If I split this into 9 equal pieces, or about 9 equal pieces, then this looks like more than one unit over here. So the answer to this one is 12. The way to do it mathematically would be to use special right triangles, but those are difficult to begin with and you have to do a lot of memorization, so I recommend on a problem like this eyeballing it. Question 30. The value of x is even and the value of y is odd. Which expression will produce an even number? So we want our answer to come out even, and we know x is even, y is odd. On a problem like this that's very generic, I pick actual numbers to use. I'm going to say x is 2. That's a pretty small even number. Y is odd. I'm going to pick 1, also a pretty small even number. And I'm going to replace every x with 2 and every y with 1 and see if we come out with an even number. So if we replace x with 2, and we replace y with 1. Then we're going to plug this into a calculator and see what we get. 2 plus 2 parenthesis 1 gives us 4. So this whole thing equals 4. Then we ask ourselves, is this an even number? And it is. Even numbers are any number that can be divided by 2 and give us a nice answer. 4 divided by 2 is 2. So 2, 4, 6, 8, 10. If you keep going up by 2, those are all the evens. Now just to show an answer that wouldn't work, because A is our answer, came out what we wanted as even. If we did B and replaced x with 2 and y with 1, we have 2 times 2 plus 1. So we'd go plug that in as 2 times 2 plus 1 is 5. That is an odd number, and we wanted it to come out even. But since A worked, that's our final answer.